Hello everyone. Today we are going to discuss about heteroscedasticity. Heteroscedasticity is another important assumption of regression analysis like autocorrelation and multicollinearity. Thus, today in our agenda, first we will discuss about what is heteroscedasticity. Next, we will see what are the causes of heteroscedasticity. Then we will look at what are the consequences of heteroscedasticity. In fourth agenda, we will see how to detect heteroscedasticity, and lastly, we will finish with one demo example on how we can detect heteroscedasticity using different tests. What is heteroscedasticity? In any regression analysis, there is one assumption called homoscedasticity. Homoscedasticity means variances of all the disturbance term is same. That is, expectation of EI square is equal to sigma square, where EI is the disturbance term. But if the condition is not satisfied and we get expectation of EI square not equal to sigma square, then we have the case of heteroscedasticity. Causes of heteroscedasticity. The presence of outliers in the data is major cause of heteroscedasticity. Again, if the data is skewed, then this may cause heteroscedasticity. Violation of regression assumptions, that is autocorrelation and multicollinearity, can also lead to heteroscedasticity. And lastly, incorrect data transformation can also cause heteroscedasticity. Consequences of heteroscedasticity. Heteroscedasticity can lead to biased parameter estimates. Also, it affects the validity of hypothesis tests and gives us inefficient parameter estimates. How we can detect heteroscedasticity? There are different tests available for detecting heteroscedasticity, but two common tests are Pagan test and Goldfeld-Quant test. Hypothesis to be tested. Here, the null hypothesis to be tested is that there is no heteroscedasticity in the data against the alternative hypothesis that there is heteroscedasticity in the data. Now, if the p-value is greater than or equal to 0.05 for this test, then we accept our null hypothesis and say that there is no heteroscedasticity in the data. Whereas if p-value is less than 0.05, then we conclude that there is heteroscedasticity in the data at 5% level of significance. Description of demo dataset. Here we have taken dependent variable as total expense of the person, and the total expense of the person is computed based on the independent variables like total income, age, work experience of the person, the number of children the person have, and also the educational level of that person. If graduated, it is taken as 1, and if not, it's 0. Now we open Excel to enter the data. As we already entered the data in Excel, here we added the dependent variable in the first column, that is total expense, and all other independent variables are entered in the second, third, fourth, fifth and sixth column. The independent variables are education, income, age, work and children. Now, after entering the data, we need to save it. For saving the data, we need to click on File and then Save As. We save the file in desktop. We select desktop and change the file name as data1. and click on Save. After saving the data in Excel, we open R programming. In R programming, first we import the saved data. After importing the saved data, we need to perform the heteroscedasticity test. For heteroscedasticity test, we need to install one package called LM test. This package is installed using the command install.packages, and in first bracket we write the package name, which is LM test. Now the R programming is going to install this package in the system, and after installing this package we need to call this package by using this command library lm test. Now we need to develop multiple linear regression model in R programming. For developing this, we need to use the command lm, and in first bracket we have written expense and is proportional to education plus income plus age plus work plus children, and then we specify the data set. Here the data set is saved under the heading data 1. Therefore we have written data is equal to data 1. Here expense is our dependent variable and education, income, age, work and children all our independent variable. Now for performing heteroscedasticity test, there are different tests available. Here we have discussed two tests. These two tests are Pagan test and Goldfeld-Quant test. Now we will see how to perform Pagan test in R. The Pagan test in R can be done using one command bp test, and in first bracket we specify the model for which we want to test. Now after writing this command we press enter and we get the result, Pagan test result as follows. Here the p-value is 0.28, which is greater than 0.05. Thus we accept our null hypothesis and conclude that there is no heteroscedasticity in the model. Next we perform Goldfeld-Quant test. For performing Goldfeld-Quant test, we write the command gqtest and in first bracket we specify the model. Now after pressing enter we get the Goldfeld-Quant test results as follows. Here the p-value is 0.3572, which is greater than 0.05. Thus we accept our null hypothesis and conclude that there is no heteroscedasticity present in the model, which means that the model is homoscedastic. Thank you for listening to me. Also like and share my video, and also subscribe to our channel Statisticians Hub.